very good morning to all of you friends. Today we are going to discuss about some sums which are based on motion and time. Okay, motion and time, that is chapter 13, motion and time. Let us see some sums which are based on motion and time. Now in our previous video we have studied about simple pendulum, isn't it? In simple pendulum we have studied about time period, oscillation and amplitude. Okay, so we have studied about time period, we have studied about oscillations, and we have studied about amplitude. Okay, now time period is the time taken by the metallic bob. That means if I draw, this is a metallic bob. Okay, it is position A. After some time it will go to position B and then to position C. Okay, so it goes to and fro. This is a simple pendulum. So the time period is the time taken by the metallic bob to complete one oscillation. Okay, so time period is equal to, how can we get time period? By the help of a formula. Here we can also write that time period is equal to total time taken by number of oscillations. Okay, so this is the equation for how to calculate the time period. So time period is equal to the total time taken by the number of oscillations. What is oscillation? Oscillation is the to and fro movement. That means from A to B, okay, A to B, then B to A, then A to C and back to A. That means the original position is A. It goes to one extreme, again it goes to another extreme, and then it comes to its own original position. So this is called one oscillation. This is one oscillation. Okay, one oscillation. Also, another way we can find out what is oscillation, that is another way to estimate oscillation, that is, suppose original position is B. So from B to A, then A to C, then from C to A, then back to B. Okay, so this is also another oscillation. So this is also equal to one oscillation. So both of them are one oscillation. That means here you can see there are four halves. Okay, so four halves are equal to one oscillation. That means 1, 2, 3 and 4. Here also 1, 2, again 3, again 4. So this is called one oscillation. Got it? Now one oscillation is the to and fro movement, and the, you can say, to and fro movement in which the bob moves from its initial position to the extreme ends and then come back to its original position. That is oscillation. Now what is amplitude? Amplitude is the maximum distance from the mean position to the extreme right or left. Okay, so the maximum distance covered by the metallic bob from its mean position. That means this is called one amplitude, or this is also amplitude. That means this distance A to C, this distance, and A to B, this distance, this is known as amplitude. Okay, so amplitude is the distance covered by the metallic bob from its mean to the extreme position. So from its mean to the extreme position, that is one amplitude. Okay, so here we can get like four amplitudes are there. Okay, because if suppose this is x, so this is also x, this is also x, this is also x. Okay, so 4x is equal to one oscillation. Now let us see some sums which are based on time period and amplitude as well as oscillations. Let me take the first example that is given in page number 200, that is activity 2. Here you will see some oscillations are given, 20 oscillations are given, and the time period is given. In the first case, the time period is given as 40.2. So let us see, this is given in page number 200. Okay, example. So let us see one example. Here what happens, it is written that a simple pendulum takes completes 20 oscillations in 40.2 seconds. That means number of oscillations, 20 oscillations. Okay, 20 oscillations numbered. It takes to complete in how many seconds? It is given, total time is given as 40.2 seconds. Okay, so 20 oscillations it covers in 40.2 seconds. Now mind you, time period is calculated in terms of second. Oscillations means the number of oscillations, and amplitude may be in terms of millimeter or centimeter. Okay. Now, what is the time period in this case? If total number of oscillations is 20 and total time taken is 40.2, then what is the time period? So, time period will be equal to total time taken. So, what is the total time taken to complete 20 oscillations? Total time is 40.2 seconds. Okay. By total number of oscillations. How many oscillations it is covering in 40.2 seconds? It is covering 20 oscillations. So if we divide the total time by 20, we will get the time period for one oscillation. Okay, we will get the time period for one oscillation. So time period is nothing but the time taken to complete one oscillation. So we are actually looking for one oscillation. So when we divide 40.2 seconds by 20 oscillations, how much you get? 20 2s are okay, 0.01. Okay, so we are getting 2.01 seconds. So 2.01 second is the time taken to complete one oscillation, and that is equal to time period. Are you getting me? Time period is the time taken to complete or cover one oscillation. Here 20 oscillations is given. So when we divide the total time by 20 oscillations, we get the time to complete one oscillation. That is only equal to time period. Okay, so this is our answer. Now let us see another example. Let us see another example. This is also given page number 200, example 1. Okay, so another example or question. A simple pendulum takes 32 seconds to complete 20 oscillations. So once again, number of oscillations, it is given as 20 oscillations. It is taking 20, number of oscillations is 20 oscillations. And what is the time taken? It is taking 32 seconds. Okay, 32 seconds. Now, time taken similar to the first one, 32 seconds. Now, this is the total time taken. That means 20 oscillations it is covering in 32 seconds. So what is the time period? That means time taken to complete one oscillation. So we will simply divide the total time by the number of oscillations. So isn't it? So the total time is 32 seconds. We will simply divide it by 20. Okay, just like the previous one. Number of oscillations is 20. So we get 10, 16, so 1.6 seconds. Okay, so this is the time period. That means this is the time taken to complete one oscillation, and that is only equal to time period. Okay, what is time period? It is the time taken to complete one oscillation. So in this way we can easily calculate the time taken to complete one oscillation if the total time is given and if the number of oscillation is given. Okay, again we can interchange. Suppose total time is given, time period is given, we can easily find out the number of oscillations. Number of oscillation will come here, time period will go there. We will divide total time by time period. Okay, we can interchange it. So if any, these are the three variables. So if any two are given, we can easily find the third one. Now let us see another example here. The movement of a bob from one extreme position to the mean. For example, suppose this is one bob. Okay, this is position A, position B and position C. So suppose the movement of a bob is from one extreme position to the mean. So extreme position to the mean. Suppose this is given. Okay, how much is it given? It can be of any value. Let it be 0.2. You can say movement of the extreme position. Suppose this is 0.2. You can say centimeter. Okay, time. This is 0.2 centimeter. Then this is the amplitude. Okay, amplitude is given here. So if the amplitude is given, then we have to calculate what is the time period. Okay, time period, how much we can get. So this is equal, this is half is given here. That means only 1/4. Just now I told you 4 halves. Okay, 4 1, 2, 3, 4. This 4 is equal to, we can say 1 oscillation. So here only 2.25 is given. Okay, 0.25 as is given. Now we will simply multiply it with 4. So we will get the oscillation. Okay, so in this case, what will be the time period? So here it will be 0.25 into 4. Okay, so this, to move from A to C, it is taking 0.25 seconds. Okay, 0.25 seconds, because we are calculating time period. Then how much time it will take to complete one oscillation? So we will simply multiply this half into 4 times. Okay, so we will get, that is 1 second. Okay, so 1 second is the time taken to complete one full oscillation. It is very simple. See, 0.25 into 4 is equal to 1 second. That means to complete this distance, it is taking 0.25 seconds. So again here also 0.25, here also 0.25, and again here also 0.25. So 1, 2, 3, 4. So 0.25 into 4, that is equal to 1 second. So one oscillation will take how much time? 1 second to complete. Okay. So in this way we can do the sums which are based on it. And suppose amplitude is also given in terms of centimeter. Amplitude means again the same thing. Suppose any one portion is given, here amplitude is given. Okay, it is taking suppose 10 seconds to complete. So it will be, let us see, suppose we can say 0. Anything we can take. Okay, 2 seconds to complete. Suppose 0.2 seconds to complete. So here also it will take 0.2 seconds. Again here also it will take 0.2 seconds. And here also it will take 0.2 seconds. Okay, so 4 times 0.2 seconds. So it will be 0.8 seconds. So this will be the time period. That means the time taken to complete one oscillation. We know 4 is equal to 1 oscillation. Because only this portion is given as second in terms of seconds. So we will multiply 0.2 into 4. So we will get 0.8 second as the time taken to complete one single oscillation. Okay, so in this way we can calculate. I will upload some sums. Please go through your book and also find out how to do these sums. And please do the assignments that will be provided to you. Thank you so much for watching this video.